I'm Sam Vanhoutte. I'm from Belgium, and I'm CTO at Codit. I'll be speaking on Azure IoT Edge today, but I also had a talk just before lunch. Who was in that talk before lunch? Okay, so for the three of you, that there might be some things that are not new if you paid attention then. For the other ones, welcome, of course. So I'm Sam Vanhoutte, CTO at Codit. That means I'm working in 7 countries. Netherlands is one of them. We have an office in Utrecht, but we are also in Belgium, UK, France, Switzerland, Portugal, Malta, and I forgot one. No, I think I had all of them, UK. There's 150 people of us, and we focus on integration, connecting systems, connecting people, Azure solutions. So we do a lot of Azure platform as a service, not the infrastructure side. And of course IoT, and that's why I'm here to talk mostly on the IoT side of things. So this talk will be mostly on the edge. I'll talk about the details later on. There's just one caveat. By the time I submitted this talk, I was still under the impression that Edge would have been already in a public preview today, but it isn't. It's in private preview. So that means I cannot talk about everything. So I can only talk about the public things so far, but you will understand the concepts, and on the architecture of Edge you will get much more to know. This is one that I include in all of my presentations. This does not contain any technology, but it shows the chain that you have from getting your data from the field all the way back into your insights. So everything on the right side of this diagram, that is where you want to create your value. That's where customers have those nice reports, have the integration, have machine learning, the big data, whatever you have. The things on the left, that's where the edge will reside, of course. That's where you have the connectivity. Everything all the way up to ingestion, it does not add a lot of value. It's just something you have to get right from the beginning. It takes a lot of time. It's very hard to do, but if you get that right, then you can start building the value. So the things on the left are difficult to do and don't add a lot of value. The things on the right are easy to iterate on and to grow the value over time. So the first thing that I'll start is the connectivity challenge. So you have devices in the field that connect and we typically see the 3 different ways. The one that most of us know with the gadgets that we might have, the smart thermostat, the smart toaster, all those home type of things. They typically have a direct internet connection. So they have their own backend service. That could be Azure IoT, but that could be anything. Sometimes it's a custom backend from the device maker. So they have a direct connectivity. They use Wi-Fi, they use maybe something local. What we also see is that you have cloud gateways in a lot of scenarios. If you look at things like LoRa, narrowband IoT, Sigfox, those are devices that have an embedded connectivity thing. They typically run on battery. If you think about smart cities and you have smart parking sensors, or you have things that measure the waste bin things and so on, you typically don't have a Wi-Fi connection necessarily there. So you will use a lot of telecom provider network connectivity, and typically they get all the data in their own cloud backend. And then you can set up integration from there. For example, on the Sigfox backend or on the LoRa backend of your provider, you will be able to forward telemetry to your Amazon, to your Microsoft, to your whatever endpoint where you want to start doing your things. So that's cloud gateways. Now the thing where Edge plays the biggest role is on the right side. That's field gateways. That's where you have existing devices, and a lot of times devices are not having even an internet endpoint, and you want to have something local that connects to it, that maybe does some pre-processing, maybe does some batching and all of that, and then forwards it all the way back to the cloud. So if you think about the building here, there's probably a lot of sensors. It won't happen that all these sensors connect directly to the cloud. It's just too expensive. Your sensor would have too much power need, compute power need. It would make it too expensive. So they have a local protocol, whatever it is, Modbus, Zigbee, name it, and you will have one or more gateways in that building that collect local data and forward all the way back to the backend. So that's where the gateways and the edge devices typically have their role. The pitfalls that we typically see in IoT projects are on the left side, as I said. is that connectivity thing, because that's also the side that is hardest to solve. If you do something wrong there and you have your devices shipped or installed in the field, you don't always have access to it. You cannot remote desktop into the devices of your customers in most of the cases. So a lot of things you have to get right from the beginning, and a lot of pitfalls can happen. Of course, it's all about connectivity. Yeah, you should never assume that connectivity is there. You can have outages if you have your truck and the truck drives through a tunnel. You will get some disconnects, right? So you might think about buffering, you might think about aggregating data before you send it all the way back into the cloud. So all the challenges that I'll talk about, these are challenges that typically get solved by edge concepts. You don't want all the devices in your building to buffer the data on their own. Ideally, you centrally buffer them before you connect it back into the cloud. The other one that we see is the retrofitting challenge. That's something you quite commonly get as a concept. So IDC, you know, the Gartner and IDC, they had a study where 85% of the devices is just not internet connected and probably never will. If you talk with industry customers in the manufacturing, they have a lot of devices that they speak things like OPC, OPC UA, Modbus, SNMP, all these traditional older protocols that exist for several years. And still they have a lot of data. So that data was captured locally in the past. Now, if you retrofit devices, if you take these devices and the data from those devices and you send it all the way back into the cloud, then you can really get some, you spin up much faster your project. Because one of these customers we worked with in Switzerland, they had coffee machines, not the ones for you at home, but the ones in the barista shops. And the generation 4 of those coffee machines had a native internet connection, so that's fine. But the generation 3 that was installed in most of the customer base, they did not have an internet connection, but they had some serial port interface. So what they did was just, okay, let's take an edge concept, let's take a gateway. They installed the gateway on a very tiny device. I think it was less than 40 euros per device. They had the gateway software running on that with a serial port. They shipped that to these coffee machines. You just had to install it, link the button, and you know, all the data got sent into the cloud. So they did not have to buy new coffee machines. It's just adding that little thing in the retrofitting scenarios really increases the adoption of your IoT solution. And then, of course, this is the one that we quite commonly see, where you have edge capabilities. You have basic edge capabilities or messaging capabilities, or where you want to do aggregation, batching, zipping, you know, compression of devices. We see that, for example, that projector that is projecting there, probably the temperature of that lamp, it doesn't change that much, right? The temperature is sending every single, is being sent every 5 seconds maybe. Maybe I only have to send the data back into my cloud backend whenever the data changes over a certain threshold, or if the value is more than 1 or 2% larger or lower than the previous time I've sent. Smart capabilities like that are typically executed on the edge and will make sure that you don't have all the data in the cloud, because that can, if you talk about 100 devices, it doesn't matter. If you start thinking about thousands and millions of devices that send every second, every 5 seconds, then it can really be smart to do some aggregation on the edge. So that could be filtering, that could be you know, with threshold values and things like that. And then, of course, the other one is security. This morning I talked about the whole concept of service-assisted communication. So where you don't want your devices to be treated as servers. Your device should never be having a public endpoint where people just can send things to, just like it is a server, because your devices are small typically, and they cannot handle, or they should not be caring about handling security, attacks and all of that. So typically you want to have all of that in your service. In this case, for example, Azure IoT Hub. They should take care of that. They should do all that security validation, that denial of service attack handling, whatever you have, and they will have that local link into your secure network. So one of the things that we've seen is that security in the IoT solutions, we always try to convince the customer that they have to do some security review or a workshop, and not by us, because if you review your own things, it's typically never, you never see the issues you should see. And then this is the one that I care about the most, except for security. That's the patching and update. It's linked with security, and it's linked with functionality and at the same time. So again, if you have your devices shipped, these devices cannot change anymore, unless if you think about this one up front. So if you ship your devices and you foresee a channel where you can update things, and that could be a lot of things. That could be changing the, pushing a new bug fix on the software of your thing, doing a firmware patch on one of those devices, thinking about just changing the value, like, oh, don't send every minute, send every 5 minutes, things like that. If you have a security algorithm that gets hacked in 3 years because of whatever evolution, you might want to push updates there. So we all know that customers really don't like updating their computers. We see how many times that gets neglected. I don't want to even start thinking about customers having to update their coffee machines or their food processing machine or their truck. They don't think about that. They don't think about them as being servers or running software, but at the same point it is needed in a lot of cases. Because if you get hacked, if one of your products get hacked, we all know that will hit the press much faster than you have a nice new concept. So that's the security thing. And then again, what we also see, if you do that together with pushing updates, pushing software updates to the devices sometimes, that adds extra functionality, then you can also take that as a business thing. We all know that if you have that energy monitor at home, you look at it the first week, the second week, and then maybe the first few months. But in the end, you know how the energy consumption goes, and you leave it there. So if you can push some new features, because I might stop that subscription because I already know what it did. But if you push some new features to that device, I might get interested in it, and people can change the devices or the behavior of devices based on how they see that customers react and based on feedback, and that is really something that is interesting as well. So it's hard to do that, but if you can introduce patch and update from the beginning, you're really in a much safer place. That were the challenges, and most of these challenges typically get handled by introducing Edge, especially in the industry. But first of all, I'd like to do a high-level overview, and you've probably seen it in other sessions as well, on what Azure IoT offers. So of course, I start with the highest level of abstraction. It's the software as a service offerings of Microsoft. You have something on the dynamic side, connected field service. I'm not too involved in that one. But you also have the IoT Central coming up. So I think you should look at it as the basic starter thing to get IoT solutions built for your devices. And it has 3 audiences. It has the operator that can monitor the devices. It sees the dynamics. It can do remote control. It's also the administrator, of course, that can set up everything. And it has the device builder. So he can define the data model. He can say, this machine has a light strength and the duration and things like that. You can model all of that. It is, however, very limited. At least the first versions will be very limited in functionality. There is 0 to almost no extensibility in the IoT Central, but they know and they realize that that is something they have to build in. So that will take a few weeks till months before you have a first public preview of that one available. Yeah, I think it can be a nice starter, but don't expect too much from it to build real enterprise solutions, at least not with the first version. Then we have the Azure IoT Suite, and I don't know if people have installed that some time already. But the Azure IoT Suite, it looks very easy. You go to azureIoTSuite.com, you do next, finish, 10 minutes, you have coffee, you have your IoT solution. At least that's how Microsoft has sold it or tried to sell it one time at a customer. But of course, it's just a sample. It's with fake devices, but you can learn nice things from it. You can see how Microsoft is building things. You can learn from it. So I take it as a reference architecture. And what I've seen with the new one that is coming up, the remote monitoring, it got announced, I think, in Ignite. It's a new iteration of the remote monitoring solution. That really looks much, much better than the one that they have. And it's also based on a microservices approach. where you can inject your own microservices. So you can say, oh, I want to have my telemetry written to my custom database. It's just hooking into that microservice architecture. So that looks promising, and the look and feel is way more extensible and looks 10 times better. The good thing is that all these things are built on the platform as a service offerings, and that's where we have built most of the customer solutions on top. So we have Azure IoT Hub. That is really the key between your cloud and your device world. And you have the device provisioning service that I explained this morning. It really helps in registering and provisioning devices in the right IoT hub. On the left side, on your device side, you have your SDKs for RTOS, Java, C, whatever you have. There is an Azure SDK for it because they know that not all the devices in the world will be running Windows 10 IoT. We all agree with that, I think. And then, of course, on the right side, you have the services where you build these nice things. Like, if you can go and have a look at the session of Alan Smith on the stream analytics pipelines, there you can have event processing. But also you have the open source things like the Hadoop, the Spark, Storm, and things like that. And then, of course, all the data things like data analytics with the data lake, machine learning, and so on. And of course, once you have your data turned into insights and information, you want to integrate that. You want to show it. That's Power BI. You want to have an integration with your remote systems. That's Logic Apps, and so on. And then, of course, everything for the rest of this talk is about IoT Edge. So that's where it fits. It fits between the devices and the cloud, right? And the cases where we see IoT Edge most interested for is the remote cases, so offline cases, and industry. So what we have seen at customers looking at Edge is the offline capabilities. So we are talking with customers that have ships that are in the ocean. So the connectivity they have is typically very limited. It's satellite based. So they want to do a lot of local processing and only send specific data through the expensive bandwidth into the cloud. So they will store things. Once they get back at the dock after the travel, they can synchronize everything locally, but they already have the most important events streamed into the cloud, and that's where they use Edge for example. Another customer is one that we talk with who's having self-driving trucks. At least they are building that in the mining industry. So think about gold mines or coal mines. And again, their mines are very remote. You don't have all that that high level of connectivity. So there again, they want to do real-time monitoring locally and send certain events into the cloud. So that's the things where offline is definitely interested. And then we have other customers where they say, okay, we want to do some local execution in the industry. If that machine sends some telemetry and indicates, hey, my temperature goes beyond a certain threshold, we don't want to depend on the cloud to take a decision. We don't want to depend on our network connectivity to shut down the other machine or to say stop processing because we have another machine in the chain that that goes crazy. So things like that is also something you want to have local. So we'll get back on that one. But first, before I dive in the details of the architecture of IoT Edge, I want to talk about IoT Hub, because everything in Edge will be based on the IoT Hub concepts. And one of these things is the IoT Hub device management. So again, I did much more details on this in my talk before noon, so you can always watch the recording if you're interested in that one. What you have is that devices that live, and you will see that Edge devices, so if you install Azure IoT Edge on a device, it will also have a representation in the IoT Hub from Microsoft. But every device that lives in the wild, in the field, has a digital copy in the cloud. And that's what we call the twin. So if I have 10 devices, they can have a representation, a digital representation in the cloud. Okay? On that twin, I can set metadata. I can specify that that device is in the RAI in Amsterdam. The other device is in building 15, and so on. So you can set metadata tags. It's all up to you. You can organize these tags yourself. It's like a structure of JSON, and I think you have a maximum of 9 levels of nesting, right? So you can do a lot of things there. I think it's limited to 8 kilobytes, however. Tags are only cloud side. So you can see the only service that can write the tags or read the tags is the service that has access on the cloud side of the IoT Hub. The device itself does not have access to its tags. And then we have properties, and that's where you have the link between the cloud and the device. So properties you have in two formats. You have the desired property, and again that is being set by the cloud side, and it's being read by the device side. So if I say that the device that I run here has to have firmware version 15, I can write through my web application, through my command channel, and I can say, okay, I'm setting the desired property firmware to be 15. This device on the left side, that device can get a notification, oh, there is a change, there is a desired property set, and it was this. It can see, oh, I have to have firmware version 15, and actually the reported version I have is 14. So I know that I have to upgrade, and it can take that as an action to do upgrades. So that's the reported and desired properties. You can do that for workflow states, like, hey, I am at this point, I'm recycling, or my connectivity at this point is through Wi-Fi, or I fall back on cellular data. Things like that. You can all write that into the cloud. And the good thing is on the right side of the thing, in your application, in your device management, you can query and you can say, give me all the devices that are at this point having a backup transport, so they are not connected on their primary transport. And based on that, you can take actions. You can say, oh, that's already going on for a while, so maybe I have to call someone and say that it seems that the Wi-Fi is gone away at your specific device. So things like that you can really set using these properties. Then this is the one that we probably all know. If you've ever seen IoT Hub, it's all about telemetry, right? And that's actually what we did with Event Hub before IoT Hub came about. And that's just sending data in a stream to Event Hub using your own device-specific identity, and that's important. It's your own identity, and that's different from Event Hub. I've seen customers saying, yeah, we don't use IoT Hub, it's too expensive, we just do inbound Event Hub. But the thing is, you don't have an identity for your thousands or millions of devices. So that's a different change around IoT Hub. And the last one you can do is writing direct methods from the cloud. So I can call a method on a device. So I can say restart. I can say shut off the light on a device. So the difference is that the things that I did through the properties, they are asynchronous. So I can set a property that it has to update to firmware version 15. I can set that even if the device is not online. Calling a direct method, that is something that happens synchronous. So if my device is not connected because the truck is in a tunnel, I will get a timeout on that call. I get a 404, like device not found. So that's a difference between direct methods and between the properties. Okay? So I think I talked about these things in quite a bit of detail. So I'll quickly do a demo on IoT Hub to show you the concepts of a twin. What is a twin? How can you do jobs? Because these concepts of twins with properties and so on, they get back and they come back in the architecture of IoT Edge. It's making sense so far, I hope. Did you see the new logo? Evolution. So this is my IoT Hub. And I should not have closed this one, but I'm opening it. So on my IoT Hub, and of course, I think we all know how to create that, I can go to the Device Explorer, and there I have some devices pre-created. Like, for example, I have a device in the Microsoft. So I gave it device ID Microsoft 7. That means it's the building Microsoft, and it's on the floor, on the 7th floor. That's just my naming convention for the device IDs that I've used. But what you can see, I can do a device twin. So I can see the actual twin at this point. And all the things that I've mentioned, let's zoom out. All the things that I have mentioned are to be found here. So of course there's a lot of overhead that we don't care about because they are internal for versioning and all of that. But I can see the tags here. So if I zoom in on the tags, you can see that these tags is something that I have set myself. So I said tags, I will give a location in the tags. So the metadata of this device is that the building is Microsoft and the floor is 7. I also set priority to true. So this can be used for a lot of things. I can set, for example, oh, this is a device that I can update in the first wave. If I do firmware updates and I have thousands of devices, you don't update all those devices at the same time, but you will also not update device by device. So you can think about a strategy where you say, oh, that's a test site, that's a customer I know well, and he agrees that he's an early adopter. So maybe that is wave 1. So I could set update wave 1. And using that metadata, I can schedule jobs later on, and I will show that in a few minutes. And here I have these properties. And as you can see, I have the desired properties and the reported properties. So at this point, these are empty. But I can write a desired property here. I can say you should use the firmware version of 1.15. And the gateway can, or the device can report back. So this is just a JSON document that you can update. And again, the tags can only be written by the cloud. The reported properties can only be written by the device. And the desired properties can also be set by the cloud side. Okay, so that's my IoT device twin. And now I will show the concept of the jobs. So for that, I first have to show you the Query Explorer. So if you've seen things like Cosmos DB, this will look very similar. So you can think about the device registry with all the device twins and the device information. You can think about it as like a NoSQL database that you can query. So what I can do here, I can say, and let me zoom in again, select star from C, and then where C dot, tags dot location dot building equals this one, for example. And if I now execute, you can see that I have all these devices returned. Maybe I will just now select the device ID. Let me zoom out. I have to close and do it again. So selecting the device ID, for example, so that I don't get everything. You can see these are all the devices that are installed in the building of Coded, right? So that's very easy, and I can use this to schedule jobs. So I can use this query and say, okay, with that query, I will now schedule a job that updates all these devices and sets the desired property to firmware version 15. That's what I did this morning in my talk. So I had 5 devices running, 3 in the building of Microsoft, 2 in the building of Coded, and I said update all the firmware versions of building in Microsoft, and you could see that those ones got the event and the other ones didn't got the update. So that is a job that is hosted by Microsoft IoT Hub, and they are taking care of that. So they schedule all these direct methods or updates for these devices, and it can be up to thousands of devices, and you can query that job for a status. So it's like the job gets queued, it keeps running, and then it's finished, and you get some report back. Okay, so that's a very interesting concept that we see coming back over time. So that was IoT Hub, and device twins were most important there. And now, of course, it's all about the edge. So especially in the enterprise, in the manufacturing and the industry, and the remote scenarios, we see that edge capabilities really make a difference in most of these enterprise scenarios. So this is the typical slide from Microsoft, but indeed it all started with cloud 7-8 years ago. Then IoT came up, and that's what we saw actually in Hannover Messe and last week in the IoT Solutions Conference in Barcelona, is that while everyone was talking only cloud 2 years ago, we saw that edge was becoming more and more and more important. So the Microsoft booth on that event last week, I think the booth with the Edge had most of the questions, next to the ones of AI and big data and so on. So you see that Edge really becomes more and more important, and it's not just cloud anymore. So the concept is clear. We have the things, and these things do their magic, and they send telemetry into the cloud. In the cloud, you have these insights, you see what's going on, you take some actions, and you can say, oh, I want to execute an action back on the device. So that's the things that we have been doing for quite a while. But you rely on your cloud connectivity. So I don't want to drive a truck or a car that depends on cloud connectivity to take intelligent decisions. That's not something we will see. What you want to have, however, is that these actions and these insights, that they can move to the edge. So you can still train these concepts, you can still define these concepts and these actions in the cloud, but you can push them so that they get executed on the edge. So that's an important one. And that's what Azure IoT Edge will do. They will execute things like machine learning and so on. You will train the machine learning in the cloud, but the model gets executed locally. So that's where we see IoT in the cloud will not go anywhere. It will still be there. People will still use their data analytics, their integration, all of those things. That will be in the cloud. But you see things move to the edge in a lot of scenarios, not in all of them. Like I said, if you take low latency decisions between machines in the field that you don't want to depend on the cloud, if you have a lot of data that you want to compress, or if you have, for example, image recognition, you don't want to do all the image recognition in a streaming manner to your cloud to take decisions. You often want to execute that locally and maybe send a result to the cloud. So things like that are really important. And again, the privacy, it's still an issue at some customers where they say, no, we don't want the data to leave our network. That's also one of those solutions where Edge can have its place. Even though Edge requires an internet connection to be monitored, to be managed, and to be configured, Azure IoT Edge allows you to have the data all locally, right? So you don't have to send your business telemetry data into the cloud if you don't want to. Of course, Microsoft really likes you to, because that's still where they will make the money. So Azure IoT Edge got announced at Build. I think that was May or something. This is the marketing slide. It is a secure platform, really from the ground up. So in combination with the device provisioning service that Microsoft now has in public preview, and the hardware security modules, you can really ship a hardware device now that is from the core, from the startup, totally secure. It does a secure call to the device provisioning service. It gets its configuration from the cloud. It starts everything up, and it's impossible to change that at any point. So that's really something they are looking at, and that sounds very promising. And then it's cloud managed. That's what I said in the beginning. If you have these devices pushed in the field, you want to make sure that you control them remotely. People sometimes post a picture if they see that, I don't know, the terminal to buy something in the airport is getting an update. Honestly, that's a good thing. It means that they can remotely update that terminal. So that's something that Azure IoT Edge also has. It's cloud managed, so you can say from your central point, from your backend, you can say that device has to get a new update. I want to push a new version of this module. I want to change the query that I'm executing. So that's really important. It's conform, as everything has to be in IoT on the cloud side. And it's portable, as they say. And the most important one is that it's extensible. We at this point are running in the IoT Edge preview with a custom container that we have. And it's just, you can inject your own business logic. And that's key. Now, you could think that this requires quite some hardware. And actually, that's not necessarily true. It won't run on the very tiny devices on the sensor tier, but it runs on of course the big servers, but it scales down all the way to 128 megabytes size of machines. So it's not that small, but you don't have to have a big device. And of course it's Windows and Linux based. Okay. And this is probably the most interesting slide. on IoT Edge on the architecture. So you can see the things that I talked about and that I showed on the right side. You can see that coming back. So the twins of IoT Hub, they have a device twin. As I said, the Edge device, so this big box is actually just one device. It's one device on IoT Hub that will run the Edge configuration for you. At the same point, the devices that I have on the left side, they can also be devices, of course. So if I have 10 devices I'm connecting and I have one Edge device in IoT Hub, typically I would have 11. Okay? So each of them has their own identity. As I said, you have the device twin and of course the copy locally for the Edge device. And on the device twin, a new concept gets added, which is called the module twin. So the device twin is for your Edge and for your backend devices. The module twin is for the different modules like the blue and the green that you can see there. So the blue and the green modules, they get downloaded from a repository. And they are actually Docker containers. So you probably have seen Docker in the past days, and there were quite a lot of sessions on that. Docker is getting into Service Fabric. Docker is getting into the Edge. So like 1 year ago, I said, yeah, Docker, that's for IT pros. I think I have to come back on that. I think Docker and containers in general are getting everywhere. And yeah, for developers like me and people in our company, that will become more and more important. So every one of those is a Docker container. So they are based on a Docker image that is in a repository. Not clear if that will be Docker Hub or Azure Container Services. That's all to be, depending on the public preview. But those Docker images, you have it there, and they get downloaded based on the device twin configuration you have. So I can set that the device that I'm starting up has these modules. So it has to have, for example, the machine learning module, the stream analytics, the functions, and the cognitive services. So those are 4 standard images that Microsoft, or standard modules, sorry, that Microsoft is thinking to push to the edge. So functions is the serverless execution of business logic. Although now you will have a server, of course, because you run it on your Edge device. Cognitive services is everything that has to do with image recognition, text-to-speech. So I've seen very nice demos recently with that. And of course the machine learning. We all know the concepts, where you define your machine learning model in the cloud. So to build a machine learning model, you need a lot of power. You won't build a machine learning model on your device. You will build it in the cloud, on the Azure Machine Learning or whatever you use. But executing a machine learning algorithm that got trained, that's peanuts. That's a few CPU cycles in most of the cases. And that you can execute locally. So the cloud to train, the Edge to execute. And that's with machine learning. And then stream analytics, if people are not familiar with stream analytics, it's like to do complex event processing or have standing queries where you have a telemetry stream and you can say, oh, I take the average over 5 minutes, or I only take, or I only output messages whenever the threshold is exceeded, and so on. So the blue boxes are standard containers, and they each one of them has a module twin. So the stream analytics container will be provided by Microsoft, and you will use the module twin to configure that container. So you will say, oh, these are the queries you have to run in that container, right? So the same thing with your machine learning. The image will be a standard Microsoft one, but the module twin, that's where I say that's the type of machine learning algorithm that you have to run on the data that you will get. So that's module twin is configuration. The blue things you get for free. On the left side we have a custom one that we at this point have. That's the Nebulous Gateway that we have built, and that is a custom module that you can run. So people and partners and customers will be able to have images deployed in the cloud, Docker images, that get treated as Edge modules, and you can push them to an Edge device, and you can use the module twin to get them configured. Okay, that's the whole concept. Now, the most important thing is that you have that runtime, the boxes on the bottom. So you have container management. You could say that's the Edge runtime that does the Docker magic. You have a functions runtime. So the functions are just used to do custom code. You have some local storage because Azure IoT Edge will have some offline capabilities where if your IoT hub in the cloud is not accessible because of internet, it will do some buffering and retries and so on. So that will be some local storage. And it has, of course, a device twin. Now, the most interesting one is the blue line. It's very tiny, but it's like a bus between all these modules. So from one module to another module, you can send data. And you can do that by configuring routes. So if people have used the Gateway SDK, the V1 from Microsoft, you could see that there were some rules there as well. So we could say we use the Nebulous Gateway to connect to devices. You can configure it there. Data that gets there will be passed on to the next module, that is the Stream Analytics, and then we will pass it on to the functions and so on. So you can chain all the messages from one container to another, and they will all be chained over the routes that you configure on that local bus. That's the concept. Okay. Timing, I think before end of this year, that's to be safely, we can expect a public preview, and then the general availability will depend on that. One of the things that is not clear, and that I'm very eager to get more information about, is the whole billing model. Because Microsoft is giving us some capabilities that we only had in the cloud before. So to do Stream Analytics in the past, it cost quite some money. So to have now Stream Analytics executed on the edge, I could think I just buy a big terabyte server and I just have Stream Analytics there, and I only have my outputs in the cloud. That's fine. So it's not clear. They don't have any public message on that, on how it will be built. But I can imagine that the Stream Analytics team, since they provide that parity, feature parity on the edge, that they will require some billing. So that's still to be seen. And then, of course, it depends. Do we really want to pay for just having a basic query that says, I take the average temperature of the lamp over 5 minutes on my own hardware? Is that something I want to pay for or not? And maybe we have to do some trade-offs depending on the business model, where we say, okay, sorry, but Stream Analytics will only be used for the complex queries, and maybe I will use some functions in case they might be free, for example, to do that basic stuff. So that's all to be seen, but I wanted to give that somewhat as a warning. So this is a little bit a high-level picture where you say, okay, we have simple processing that you can do on all the different places in your IoT scenario. Then the more complex scenarios, you can also push from the cloud into the field. I only have 1.5 minutes left, so I won't do the demo on the concepts. But actually these edge concepts we have implemented already together with Microsoft with the Nebulous IoT Gateway. So what we have there is that we also have a cloud managed platform as a service, where you have a local edge device that runs software on the hardware that you define. You can configure everything from the cloud, so you can say, oh, the data from that projector, you have to get it through that TCP adapter. You can inject your own adapters and push adapters from the cloud, even when the device is running. But what is important is that we take the decision, and I think more and more partners are doing that, that if you take data from the devices, that we don't get the data in our subscription. The data streams directly into the subscription, into the storage accounts and so on of the end customer, because that's where privacy really comes in, privacy and trust. Customers are really happy if you provide that management as a service, but they really don't want you to have a look in their data. And if you stream that directly to their cloud, that's really much more interesting for them. So that's just, I won't do the demo here because I'm running out of time. I'm happy, of course, to talk about this, to talk about IoT Edge. As I said, it's not a deep dive because it's still in private preview, but it's all a matter of a few weeks, maximum a few months, before we all can get our hands dirty on that one. I would say thank you for the time. Any questions, don't hesitate to contact me, and see you next time.